Hello everyone, I hope you're all doing well. So once again, we have your video presentation and what's in today's basket. So we will be dealing with NAT, the different types of NAT and how do they uh, or how are these NAT configured in your router. So first, what is NAT? NAT, or the so-called network address translation, is a process of changing the source and destination IP addresses and ports. Your NAT reduces the need for IPv4 public addresses. Take note, public addresses. And also, your private network addresses are being hidden by the network address translation. Paano kaya? Makikita natin mamaya. Paano nangyayari or how does the NAT works? So network address translation works in two-way process. Okay? We all know that this network address translation is, of course, a service used by routers. This NAT translate a set of IP addresses to another set of IP addresses. What are these IP addresses that being transferred to another set? Your private IP addresses. These private IP addresses, which is of course from your private network or being used by your computers at home, for example, that are connecting with the internet, which has the public IP addresses. Okay, so let's say we have a computer asking for a service from a specific website, but before it reaches that particular service from the website or from a specific computer, the router mediates between the two or in the network. Okay? The router translates this IP address and seeks for a specific address, which is a private IP address. And the computer or the service being requested by computer A, for example, sends back its specific answer. Okay? And then, through the router again, the public IP being used by the server, for example, is being translated to private IP, which is now directed or message is being directed to the specific computer as the service in the first step. Okay, so that's how simple your NAT works. Okay, but how does NAT helps preserve the limited amount of IPv4 public addresses? Take note, your computer A does not use a specific public IP address, but it uses a private IP address. Only that it can use a public IP address or it can be assigned with public IP address when it reaches or uses the internet. Okay? So kapag gumamit tayo ng internet service, it means na meron tayong katumbas na public IP address. Say for example, mamaya makikita natin how do we look at the public IP address of assigned to our computer system. Makikita natin mamaya. So, bakit na-develop si NAT? It's because of the IPv4 public addresses. It's not the private one, but the public addresses. So, engineers before developed the IPv4. Didn't realize how big the internet would become. So ganito, no? They created the IPv4. Ang akala nila, with more than 4 billion IPv4 public addresses, akala nila masusuffice na yung requirement. Pero hindi nila in-expect na lumobo ng lumobo yung ating internet. The requirements of public addresses increases every moment in a day. Take note of that, ha? Every time na meron tayong bagong computer na kinoconnect, meron siyang katumbas na public IP address which is from the available public addresses. Now, as I've said a while ago, paano natin makikita yung ating sariling assigned public IPv4? So, if you don't mind browsing your public IPv4, punta kayo sa whatismyip.com. So, this one is my assigned IP version 4, public IPv4, assigned to my own computer. So, this is a private one since this is my personal computer. I don't wanna let you see my public IPv4. Baka mamaya may nag-hack na ng aking computer na hindi ko alam. Okay? Now, still, why NAT was developed? NAT is a solution. So, they developed NAT as a solution. Paano? NAT and private addresses were developed to solve the issue of course, the number of public IPv4. Medyo paunti na ng paunti. So, public addresses, take note that these are publicly registered on the internet and must have a public IP for a specific computer to access the internet. On the other hand, the private IP addresses are those not publicly registered on the internet. So these are your IP addresses you use in your computers at home whenever you configure them as static or dynamic ones. Or if you want to see them, you may browse them through your adapter and then look at the properties and so on. And they cannot directly access the internet with private IP. And of course, these IP addresses, the private ones, are used internally. Okay? So with your own networks at home, you may use private IP, of course. So what is the future of NAT? With IPv6 as the other version of our IP addresses, there will be no longer NAT because this IPv6 as the new generation of IP addresses, every device will have its own public IP address. So 1:1 na yan. Imagine with IPv6 capable of producing 340 undecillion IP addresses. That's 340 plus 340 plus 36 digits after it. Yan yung nasa baba. So imagine how many. Yung existing natin, which is of course, andito lang siya, yung range na to. It's 4 billion plus. Napaka-konti compared to the public IP addresses that can be provided by our IPv6. Okay? So NAT and private addresses will no longer be needed. Types of NAT. What are the different types of this NAT? There are three types: static, dynamic, and of course PAT, which is port address translation. Ano yung pinagkaiba-iba nila? First one, static NAT. This one translates one private IP address to a public one. Not often used because it requires one public IP address for each private IP address. Say for example, you specify that your uh, laptop at home uses a specific public IP address that you have requested. No? So medyo hindi ka aya-aya ito si static, hindi siya masyadong ginagamit, no? So there are three steps, of course, to configure the private and public addresses. You have to use IP NAT inside source, static, and then the private IP and its public IP command. Okay, this is the command, okay. And of course, the next step would be configure the router's inside interface. Okay, so yung interface connecting to the uh, device in your own private network. Okay, so IP NAT inside. And then of course, configure the router's outside interface naman, no? This one, the outside interface, of course, is the interface being used by the router to or connected to the internet. So say for example, dun sa LMS, this is your example there. Um, the router, which is R1, is configured to its um, network address translation. Okay, so the source IP NAT inside source static, okay, with the given IP address sa loob, that's 10.0.0.0/24, and its equivalent outside interface. Excuse me. And for the first interface given as the IP address of 10.0.0.2 is for FA0/0. Okay, that's for the IP address inside, no? And FA0/1, okay, this one is connected to the outside world. Okay? Yan. So itong si um, FA0/1. Okay, dito siya. FA0/0 is of course the private IP. Now, if you have configured that already, okay, you specified the commands for configuring the NAT inside and outside interfaces of the router, then you may see the actual configuration using the command show IP NAT translation. Okay, almost all of the different types of NAT uses this method or steps. Only that there are additional steps for dynamic and path. So for dynamic, the mapping of a local address to a global address happens dynamically. Okay, take note. With what had happened to our static, we map manually in our router. Dito, si private and a specific public address, they are being mapped dynamically. So, random. No? Whatever the available public IP can be used by a specific computer when it is configured dynamic in its network address translation through the router. So the router dynamically picks an address from the global addresses pool or address pool that is not currently assigned. So it doesn't pick an assigned IP address or a public address. No? And the dynamic entry, sorry for this, this is a typo. This should be THE. The dynamic entry stays in the NAT translation table. Okay? So, together with other types of network address translations, the inside and outside reference to the IP addresses of the private network and the public network are being uh, recorded in our network address translation table as long as the traffic is exchanged while they are uh, requesting and submitting the request. Okay, the entry times out after a period of inactivity, and a global IP address can be used for new connections or requests by other computers connected to that particular network. So kapag binitawan na kasi inactive siya, yung public or global address na yun, pwede nang gamitin ng iba. Okay? So, paano ba yun? Ginagamit ng iba. So, configuring dynamic NAT, there are 5 steps. In this case, the access control list is included because, of course, the list of the inside source addresses must be translated. Okay? So, first, configure the inside interface of the router, and then the outside interface, and then yung ACL na sinasabi ko, and then also configure a pool of global IP address. No? Si router na bahala dito. No? But you have to specify that this particular IP address will be used because for dynamic IP addresses, no, medyo magastos ito kasi you have to uh, purchase a set of global uh, addresses from your ISP. Okay? So, ibibigay nila yung IP list sa'yo, doon kukuha si router mo pag magko-connect ka. Okay? So, doon siya magpipick ng global address. Okay? And enable dynamic NAT with, of course, the command IP NAT inside source list, ACL number pool, ACL number, then the full name of the global configuration. Okay? So, say for example, host A to a server 1. No? So, fast Ethernet 0/0 in your R1 and fast Ethernet 0/1 again in your router 1. For FA 0/0 for the private IP and FA 0/1 for the public. Okay? And then, of course, our access list, which is, of course, we will let 10.0.0.100 to access any or specified public address. And the IP NAT pool, say for example, the given is, of course, 155.4.12.1. Okay? Up to a specific IPv4 155.4.12.3 in your global address pool from your ISP. And of course, the net mask. And if you again want to know the uh, network address translation table, just type in the command show IP NAT translations. Okay? So, ipapakita niya yung inside and then outside IP addresses. Okay? I mean the private and public addresses. So, note, dynamic NAT needs to manually create a pool of public addresses which will require you to purchase from your ISP. Ito na yung range. Okay? So, kung in this case, ang binili mo, for example, from this from 12.1 to 12.3. So you only have three uh, uh, list of global addresses para doon siya magpipick. Okay? How about PAT or Port Address Translation? In this case, um, hindi na kailangang bumili ng list of global IP addresses. But it uses port numbers. Okay? This port address translation, also known as the NAT overload, is a typical form of NAT, okay, na ginagamit sa mga networks natin ngayon. Kasi port by port ng usapan. No? Whenever you try to access a specific service or whenever you use a specific service. Okay? So lahat halos ng mga routers na nabibili sa market, sinusupport na si PAT or Port Address Translation. So with Cisco, of course. Okay? So PAT overload. Say for example, I have here the IP addresses and its port. Okay? Specified ports. Whenever this particular addresses request for a specific public IP address, it matches to a specific public IP addresses. No? But the returning message or the response will throw back to the same port kung saan nag-request si private IP. Kung ano yung nag-request na port from the private IP. Okay? So, ganun lang yung batuhan nila, no? If this is TCP, no? Then, TCP port 1055 will receive a response from a public IP address with its TCP port. Okay? So, ganun din with other types of ports. Babato lang sila and then magre-respond doon pa rin. Okay? Okay? So, if these are your ports, port numbers, it matches. No? Nagmamatch lang sila ng port numbers. So, configuration, there are 4 steps. First, the inside interface, then the outside interface configuration, then access list naman tayo, and then you enable path using this command. Okay, ganun lang kasimple. So, that's it for the different types of uh, network address translation. Ito pa pala yung ating example. No? So, doon sa network kanina, balikan natin. So, this one, gigabit 0/0 and gigabit 0/1. This is for the private. Let me just clear the screen. Okay. So, in this case, gigabit 0/1 uses IP 155.4.12.1 and it matches to a specific IP address with the range 10.0.0, okay, 100 to 102, okay, with its specific port numbers assigned. Okay, balik tayo dun sa codes. So, the first IP address, this is assigned to our private inside, okay, not inside. So, makikita nyo kung ano yung kinonfigure yung interface sa router, no? I-specify nyo siya as not inside, no? And then, kung ano yung nakakonect naman sa internet na interface, yun ang i-specify nyo na not outside. Okay? And then, of course, the access list, you let the permission set to 10.0.0.0, okay, which is, of course, from that particular network, 10.0.0.0, anything, no? Any addresses after 0, no? With this network, 10.0.0, can match or can be given permission by the router to go out. No? And then, of course, the IP NAT inside source list will be assigned, overloaded to a specific outside interface, which is now your gigabit 0/1. No? And then the keyword overload that specify that you are trying to configure your port address translation. Okay, so that's the three different types of network address translation. First, the static, which assigns 1 to 1, and dynamic, which uses specific global addresses, and your path, which uses port numbers. Okay? So pag nag-show IP addresses tayo, show IP not address translation, I should say. So these are again the result of our show request. So for the learning tasks, so sabi dito, very simple lang yung task ngayon. You are the network administrator at RayNet and have to configure the RayNet GW router via console. So ito, using this particular console terminal, okay? Kasi si router, wala siyang keyboard saka interface, wala siyang mouse. So, pag may console port kayo, dun kayo mag-configure lagi, no? Kaya nilalagay dun sa command, through console. Okay? To let host in our LAN, ito daw, so lahat ng RayNet host, lahat ng host natin dito, okay, have IP address 192.168.193.206 can connect to the internet. Okay? Your ISP has given global IP for 6IP as 25.25 25.5.565 to 255. Sorry, 25.5.5.70. Okay, remarks 1. Use ACL number 1 for local IP list, and 2. Use full name RayNet for global IP list. Okay, so that's for the learning task. I've seen there are a lot who submitted the learning task already. Anyway, this is from your CCNA lab. So you can browse different sources for your learning task. Okay, thank you.